a dry dock problem here, that we're floating in dock water now, and we've got our drafts. We're about to dry dock and we want to calculate the effective GM at the critical instant. So I know I keep saying this, but it's so important that you know which formulas to use. Write the formulas down, and once you've got the formulas, you know which ones you're going to use. Hopefully you can simply feed information into the formulas and solve the problem. So we're given our drafts. We're in dock water, so we have to be a bit careful here. So what we need to do is work out one or two values initially using our drafts. So we have to get our displacement, LCF, MCTC. To get those, we need our true mean draft. So the standard procedure: get your arithmetic mean draft, LCF from the tables, work out your true mean draft. And don't forget, it's always draft F minus LCF over length between perpendiculars, providing you're trim by the stern. Multiply that by the trim, of course. So true mean draft is 6.003. We go in the tables and we get LCF, MCTC. Now, what you have to do here, because you are in dock water, you would get the freshwater value of MCTC and multiply that by the density. With regard to the displacement, you would get the freshwater value, which is the underwater volume, of course, the same thing, multiply that by the density, and that gives you the displacement in dock water. Because we know the MCTC and the LCF and the trim, because don't forget, when we reach the critical instant, the trim will be 0, or just before we reach the critical instant. We talk about a critical instant, it's from touching down on the block aft to just before we touch down forward. But we're assuming that all 132 centimetres are gone of the trim. So we know what the total trim change is. We've looked at the MCTC and the LCF. We can work out that the total P force acting through the stern is 324 tonnes, just as the vessel is at the critical instant. So we know that value. What you've got to always be aware to do here now is work out the displacement at the critical instant, and what we're saying is we have to take this P force off that displacement. The P force acting up is taken off the displacement, and the reason we do that is because we have to find the Km at this point. That's why we need this displacement. The only reason is to get the Km. Because we're in dock water, then we have to get the volume of the displacement. So we get our displacement here, divide it by the density, gives us our volume of displacement, go in the freshwater column, and it gives us our Km of 8.57. Because we're in dock water, we can't use the saltwater or freshwater columns for displacement. So we have to use the freshwater column for our volume, and that will give us our Km. So now we know the Km, we know the P force because we've calculated that. Be careful here, our weight, our displacement doesn't change, so it's still this displacement here. We've got to use the proper displacement here. The only reason we get this critical instant value is to obtain our Km. Put those in the formula and we find our loss of GM is 0.23. Okay, we're losing 0.23. So our Km at this point is 8.57. Again, you must use the Km at critical instant. Kg doesn't change, 8.3. So the GM of 0.27, let's apply our loss of GM to that at 0.23 that we've calculated, and we find that our GM at the critical instant is 0.04 of a metre. Okay, so standard procedure here, always get your true mean draft, LCF, MCTC, displacement of the vessel, and then use the formulas, the two formulas to solve the problem. Now the second part says, okay, what can we do to perhaps alleviate the situation and make the vessel more stable? Well, two courses of action. We can increase the GM, lower weights or ballasting a double bottom. So in other words, get the GM bigger. So when this value here would increase, so we apply the loss of GM, therefore our GM at the critical instance will increase. and we can reduce the initial trim. As we can see here, that if our trim is reduced, then obviously the P-force will be less. If the P-force is less, then the loss of GM is less. So reducing the trim or increasing the GM are the two courses of action available to make the stability of the vessel better, increase the GM of the vessel. Okay, so the two formulas, write those down, feed the information into the formula, and you should be able to solve the problem. Remembering that if you're not in salt water or fresh water, you have to be careful with the MCTC here. You have to get the freshwater value multiplied by density, and obviously the underwater volume, which is the freshwater value for the displacement, multiplied by the density.